Hi everybody, welcome back. Today we are going to do some more word problems that involve completing the square. Okay, so we have a farmer who has 120 meters of available fencing and he wants to make an enclosure that looks like this. So a big pen subdivided into 1, 2, 3, 4, 5 pens. He wants this area, the entire area, to be a maximum. Okay, so how do we do that? Well, first thing we want to do is we want to assign variables to the two lengths. Okay, so we're going to call this length x and we're going to call this length y. Now, we have another length y here and length x's all the way across here. So we need to set up two equations. One equation is what I like to call a fence length or a perimeter equation. Fence length is a little bit more accurate to call it because it's not just the perimeter, because these don't really make a perimeter, but you can call it either one, it doesn't really matter, fence length or perimeter. So we'll use P for perimeter. So the perimeter equation is 1, 2, 3, 4, 5, 6x plus 2y. Okay, or fence length if you will. Fence length equation 6x plus 2y. Now we know what that fence length is. It isn't an unknown, so what we're going to do is replace the p, or the fence length, with 120. Okay? The other thing that we want to do is make an area equation. So these are your two equations. You've got your perimeter equation and you've got your area equation. I'm going to put a little m at the bottom there, and all that means is area maximum. Okay, that's what that little subscript means. And the area of a rectangular object or whatever is just x times y, length times width. So what we want to do is maximize the area given the fence length that we have available, the available fencing material, and these cross sections that the farmer wants to do. So what we need to do is put this equation inside this one. So you need to solve this equation here for either x or y. It doesn't matter which one. Sometimes it's easier to do one than the other. In this case, they're both easy. So I'm going to solve for y. So I'm going to go 120 minus 6x is equal to 2y. So all I did was move that 6x over. I subtracted it from both sides. And now we're going to divide everything by 2, which is going to give me 60 minus 3x is equal to y. Now that y, I'm just going to draw a little lasso around this, that y is going to go into the y of that equation. Okay, so here's what it's going to look like. Our area is going to be x times 60 minus 3x, right? Now what we're going to do is we want to set this equation up so that it's in ax squared plus bx plus c form so that we can complete the square on it, because we want to find the maximum, which is going to be the top of that parabola. So moving these terms around right away, negative 3x squared plus 60x. So all I did was multiply the x through the brackets. X times negative 3x squared, x times 60 is 60x. I want you to notice that there's no constant, okay? And the reason for that is because the area, if x was 0, would be 0, right? So I could put that out here. And I could say, okay, well, if this length is 0, what's my area? Well, it's 0, isn't it? Okay? So obviously we don't write the 0 there, but just so that you know why it's 0. It's because, again, if x is 0, we don't have an area at all. Okay, so now we want to complete the square. So we're going to go, remember, we take out anything that's sitting in front of x squared, and anything that's taken out of the x squared term must also be taken out of the x term. Leave a space for the magic number and push the constant to the outside. Now there is no constant in this case. So all we do next is we take this number, remember the minus doesn't matter because we're going to square anyway, so it's going to be positive. We divide that number by 2, we get a result, we square that result, and that number goes here. Now what we've changed this equation by doing what we did here, is minus 300. Do you see that? Because what happens is, if I took the brackets off, here's what I'd have. I'd have negative 3x squared plus 60x minus 300. Well, that minus 300 is not here, is it? So we've actually changed this by minus 300. So to not change it, we have to add that 300 back. Okay, it's our balance number, right? Okay, and then we're going to write this in completed square form, which looks like this. Okay, so remember, when this is a perfect square trinomial, the work that we do here ensures that. That's what we're trying to do, that's what we have to do. And a perfect square trinomial always factors. So when you're doing this, okay, you could look at the perfect square trinomial and you could say, okay, how do I factor that? How do I factor this? Right? Well, you probably eventually write that. And that's exactly what this is, right? X minus 10 all squared, that's exactly what we have. So what you're doing when you write this step out is you're putting down an x. It's always going to be an x because whatever you had in front of x squared has been pulled out. It's always going to be this sign, and then you're going to write half of that number or the square root of that number. Take your pick. It's going to be the same number. Put a squared on the outside and then collapse those outside numbers. Usually there's going to be more than one. So what does this tell us? Well, it tells us that the area will be a maximum when x is 10. Okay? So on a graph, here's what that looks like. I have to be careful not to run out of room here. So this is the x dimension of the field. Could have been y. If I had solved this for y, this here, or sorry, if I had solved this for x, then this would have been in y. And then this would have been the y dimension. Still would have worked. And this is your area. Okay? So if x is 0, the area is 0. It has to be, right? If x is 1, then the area is, well, it's not a very large area. X is 2, x is 3, if x is 4, and so on. You can figure this out yourself, etc., etc. And when x is 10, we have a max area of 300. It's critical to understand what X represents in these questions, okay? Whether they're revenue questions or farmer's field questions, you're going to get a lot of these on tests. You will see a question like this guaranteed on a unit final or a grade final that covers this material. You're going to see questions like this on those tests, so make sure that you understand how to do these. We've got lots of other videos that go over word problems that involve completing the square. But the critical thing to know or to understand is, what does the x-axis represent? In the case of revenue questions, it's usually the number of $2 increases in the price of the shirt, or the number of 5-cent decreases in the price of the ticket for the cruise, or whatever the case may be. So it's critical to understand what that is, because without that understanding, it's really hard to answer the question accurately. So what is the area, or what are the dimensions going to be? Well, we know that x is going to be 10, okay? So now you can take your perimeter equation and you can solve for y, right? So, because now we know that x is 10, so we can put a 10 in for x, and then we can do that, and we can divide by 2 and get y equaling 30. So this is 30. Okay, so is the area what it says it is? Yeah, it is, right? Because 30 times 10 is 300. So when you get to the end, if the product of the two things, the number of shirts being sold by the new price of the shirt, or the y dimension times the x dimension, if that doesn't give you this number here, something's gone wrong, okay? So again, very important to understand what that x-axis represents, what this horizontal variable represents. Okay, that's it for this video. Give us a thumbs up if you liked it, and share widely. Talk to you next time.